Could you, Mom, could you?
All right. So we've got. Oh, you're singing "Happy Birthday"?
Oh, let's sing "Happy Birthday" to Rufus.
All right, it's the dog's birthday.
Happy birthday to you.
While they're doing that, I'm gonna write the triangle.
Happy birthday to you. Happy birthday, dear Rufus. Happy birthday to you. Why is it? Yeah, he's
Okay.
gonna get a brain freeze.
All right, so this is Pascal's triangle, and it's necessary when you do binomial expansions. We have 3 strands when we do binomial expansions. One is the triangle, one is descending order of powers, and the other is ascending order of powers. And from your perspective, that would have been the opposite. Okay. So what we need then is, if we're raising this to the 3rd power, we would use the 3rd row that has the 3 in it. Okay, which is really the 4th row, but we're counting from 0. And this is the 3rd row, so we would use this. Wow, this is the same, almost the same problem. Okay, we would use this row right here, and what we would do then is we would. Do we have another? I think we got a full expansion question. Right? Yeah. Okay. Good. All right. So what'll happen then is that we would do u to the 3rd, and then because it's negative, we would go minus u to the 2nd plus u to the 1st minus no u. Okay? And then we would have 5. And 5 would be 5 to the 0, but then 5 would be right here to the 1st, 5 to the 2nd, and then 5 to the 3rd. Okay? And then we've got the triangle numbers, 1, 3, 3, 1. So 1, 3, 3, and 1. Okay. So the way that this plays out is this would be y to the 3rd, and then we would multiply these two. So that would be 15, but he's still going to be negative. And we've got 15u to the 2nd. And then we've got 25 times 3 is 75, but it's going to be positive, and then the u is there. And then we've got minus 5 to the 3rd times 1, which is 125. All right. Now, it's just asking for the 3rd term, so we would just circle that guy. Okay, so that's B. All right. Now, this guy is the same process. We go x to the 3rd minus x to the 2nd plus x to the 1st, and then there is no x, right? And then we would do 5 to the 0, which is just 1. So then 5 to the 1st, 5 to the 2nd, 5 to the 3rd. And then we grab our triangle numbers, 1, 3, 3, 1. All right. So then we would do the same thing, and you'll notice that the numbers are still happening, but we just want the first term in the expression, and it's just going to be these guys multiplied to each other. So that's it. All right. All right, so for full expansions, okay, we're going to need the triangle. It's going to have to be, we're going to need a bigger triangle here. So, in fact, I'll just use the back of this. And it looks like I need to go to 7. But what we'll do is we'll stop once we notice that, the multiple choices kind of played itself out. Okay, so let's go 1, 1, 1. Now, how do you reconstruct this? If you remember, you just add the 2 above it. Oops, 1, and you always have 1s at the edge, okay? So 1 plus 2 is 3, and then we've got 1 on the edge, so 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 on the edge. Then we do it again, 1 plus 4 is 5, that's 10, and then 10 again, and then 5, and then 1. There's always a nice little symmetry to it. All right, and I'm going to go all the way up to 7 just because it's going to be necessary for 42. All right, so 6, 15, 20, 15, 6, and then 1, and then lastly 7, and then add those two, 21, 35, 35, 21, 7, and that. Okay, so looks like we're going to be using the 5th row, so that's 1, 5, 10, 10, 5, 1. All right, let's try it a different way now. What we'll do is we'll do the triangular numbers first. 1, 5, 10, 10, 5, 1. Okay. This way we actually know exactly how many we have, because remember we're 1 short every time we use one of these guys because they go to the 0 power. Alright, so we've got x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, and then x, and then the 3 is going to go 3 to the 0, 3 to the 1st, 3 to the 2nd, 3 to the 3rd, and then 3 to the 4th, and the last one will be 3 to the 5th. Okay. Now, because it's negative, we'll just alternate each of them. So I'll have my calculator with me in case the numbers get large, which they often do with these. So 1 times x to the 5th is just going to be x to the 5th. 5 times 3 is just 15, but remember we alternated, and then we've got x to the 4th. And then we have 9 here times 10, that's 90, but it's going to be 90 there. And then we've got x to the 3rd. The next one is going to be 27. 27 times 10 is 270. X to the 2nd. 3 to the 4th is 81. 80, that's 405, and that'll be positive. And we got x, and then we got 3 to the 5th, and that one I forgot, that is 243. Oh, and that should be minus 243. Alright, so x to the 5th, cross out b and d, and negative, so with the second term we could have figured out that this guy is good. Now we did the whole thing just so that you know that if you go farther down the chain, you'll be careful, okay? Alright, so now we need row 7 for binomial expansion. Row 7 is, I'm actually going to do it right here. Okay, 2 in n. Okay, so luckily, that's not too bad. We're going to spread these out, though. This one I'm going to be really careful with. Okay, and then I got 2 and then n. Alright, so 2 gets raised to the 7th, then it gets 2 to the 6th, 2 to the 5th. These are going to be really large, actually. 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and then 2 to the 0, which I won't even write. Alright, and then the n actually starts at n to the 0, but then n to the 1st, n to the 2nd, n to the 3rd, n to the 4th, n to the 5th, n to the 6th, and then finally n to the 7th. Alright, so again, notice that we're missing a value there because it goes to 0, and we're missing a value here at the head because that guy is to the 0 power. Alright, we could put a 1 there as a placeholder, but that's fine. Okay, so now what we're going to do is we're going to go ahead and just multiply going down. This is a positive, so that's convenient. We don't have to worry about forgetting the alternating process there, so we're just going to go straight across. 2 to the 7th, I have no idea. That is 128. Okay, plus 2 to the 6th, I believe is 64. 64 times 7 is 448, and it's going to have an n to the 1st power. Plus 2 to the 5th is 32. 32 times 21 is 672. N to the 2nd. 35 times 2 to the 4th, which is 16. That is positive. 560. Oh, you guys can't see my calculator here. Okay. And that's going to be n to the 3rd. All right, now let's pause for a second to see if we've got... Okay, 128, so we can cross out these two. And then we've got 448n. It looks like A is the answer. Okay, and just know that these numbers come from multi-list. In fact, let's check. How about that 14n to the 6th? Let's see. 7 times 2, that's 14. 14n to the 6th. Okay, so it checks out. And we can stop there. Okay, and remember, that will be multiple choice for that type of question. Okay, so where are we at? 9 minutes. We'll go to the next video.